Alright, good everybody, this is Ajax Tutorials and welcome back to my YouTube channel. Okay, now in today's video we're going to be looking at JAMB past questions on ideal gas equation. So please, I want us to pay attention to this video as I'm going to be explaining things that you might not know. Alright, so just pay attention. Now, before we solve any question on ideal gas equation, I want us to first I want to give you some formulas to note, and not just formulas, some terms to note. Okay, because let me just tell you the truth, JAMB chemistry is not all about calculations. There are some things that you might be asked. Okay, now pay attention. Now when we talk about ideal gas, so we are looking at ideal gas equation, but first let's discuss what an ideal gas is. Just pay attention. An ideal gas, this is a gas that obeys what? Charles' law. That obeys Charles' law and what? Boyle's law. So I hope you have not forgotten Charles' law and Boyle's law. Charles' law states that what? The volume of a fixed mass of gas is directly proportional to what, class? The temperature, provided that what? Pressure remains constant. Okay, so Charles' law talks about V is directly proportional to T. Are we following? And Boyle's law says the volume of a fixed mass of gas is inversely proportional to the pressure, provided that temperature remains constant. Okay, now Boyle's law talks about V is inversely proportional to P. So any gas, take note, any gas that obeys these two laws is called what? An ideal gas. Now note this, for a gas to be said to be ideal, it has to be in low pressure and what, class? High temperature. Now I want to say something very important. I want you to just pay attention. A gas is said to be ideal if it's at what? Low pressure and high temperature. Now once a gas is at high pressure and low temperature, I'll tell you the name, but not now. This gas is no longer ideal. Now these gas are said to deviate from ideality. Now pay attention. If a gas is deviating from ideality, there are two factors responsible for this deviation. The first factor is that it has a higher intermolecular forces. All right, and the second factor that is responsible for a gas to deviate from ideality is when the gas is what? Less energetic. Yes. So these are the two factors responsible, okay, for what? A gas to deviate from ideality. Now they can ask you, remember this is a JAMB question, so they can ask you, what are the factors responsible for what? A gas to deviate from ideality. The first one is intermolecular forces becomes higher, that is, the forces become appreciable, okay, and what? The gas becomes less energetic, and if it's less energetic, it becomes what? More sluggish. Now take note, a gas is said to be ideal at low temperature, at low pressure and high temperature. It deviates from ideality at high pressure and low temperature. So it's not all about calculations. Just take note of this point. Now, as we have understood this whole thing, let's now go into ideal gas equation properly. Now pay attention. PV equal nRT equal what, class? nRT. Now let me explain what this is all about. Now PV equal nRT is a combined equation. Are we getting me? It's a combined equation. You know, I told you earlier that ideal gas what? Obey Charles and Boyle's law. So this is a combined equation from these two things. Is that clear? Good. Now take note of something. There's something I not mentioned here. Regardless that Charles' law is telling you that temperature is constant, also note, Charles' law says pressure is constant. Note, N is also constant here. N is also constant here. Yes. Are we getting me? Avogadro's equation. Take note. Now let me continue. PV equal nRT. Now P is my pressure. In chemistry, when you move further, you'll be seeing sometimes in physics pressure can be in millimeter mercury. That's mmHg. But in chemistry, your pressure is most likely in atm. All right, so let me just wipe this off so we can see enough place to solve. So just pay attention. Your pressure is in what? atm. So in case they might not tell you in the question that is pressure, they just tell you so, and you need to be atm. Just know that's what? Pressure. Now what of V? V is called the volume. Volume can be in dm cube or cm cube. It depends. But when you are using ideal gas equation, take note, your volume must be what, class? dm cube. Is that clear? Good. Now your N is your number of moles. Your R is your gas constant. So R is what? Gas constant. So it's not all about solving questions. The moment you know the terminologies, you'll be able to solve questions properly. Okay? Now your T is your temperature, and your temperature must be in Kelvin. If your temperature is not in Kelvin, my brother, my sister, you are going to be wrong. So your temperature is in Kelvin, and not this easy conversion. We are going to do it in this video. When you want to convert degrees Celsius to what? Kelvin, what do? You add 273. So it basically says that a Kelvin is equal to a degree Celsius plus 273. Is that clear? Good. So just take note of the formula, write it down. I'll soon clean it. Okay? Now, there are things we should note again before I move to calculation. When can you use PV equal nRT? Because this is also very important to note. When can you use PV equal nRT? Now, the first case to use PV equal nRT is when you are looking for either P, V, N, R. No, you don't need to look for R now. R is, that's true. Let me give you the formula for the value for R. Then I told you R is a gas constant, so it has a value. R is what? 0.082. Now pay attention to the units. Pay attention to the units. The unit is in what? ATM, dm cube, mole per, Kelvin per. Is that clear? ATM, dm cube, mole per, Kelvin per. Take note, because sometimes this can be in kilomole. If this is in kilomole, this is normal 0.028. I mean 0.082. But in chemistry, like I said, this is what you'll be using. Okay, so don't worry. Now, where are we? So I was saying that when can you use PV equal nRT? Number one, when you're looking for P, V, N, and T, you use this PV equal nRT. Okay. Now, secondly, is when you want to find what we call the compressibility factor. Plus, compressibility factor. It's a JAMB question you can be asked. How can you find compressibility factor? Take note of this formula. CF is equal to PV over what? RT. Yes. CF, compressibility factor, equal to PV over, in case you can't spell compressibility, let me just help you. Compressibility. Yes, this is it. So compressibility factor, you use PV over RT. Now, having understood all you need to know on ideal gas equation, I hope you haven't forgotten. And a gas is said to be ideal if it's what? At low pressure and high temperature. It deviates from ideality when it's at what? Low temperature and high pressure. And now note, when a gas deviates from ideality, it is called what? A real gas. It's called what? A real gas. So these are things you should note. It's not just calculations. Put this in your head. Is that clear? Good. Now let's dive into the calculations and ideal gas equations. So I'm going to be solving some questions for you. So watch this video till the end. And yes, do well to subscribe if you're enjoying this video. Let's move to questions. Alright, now let's move to questions on ideal gas equations. So you're going to see the question on your screen now. Good. Question 1 says 0.79 gram of a gas at STP occupies a volume of 250 centimeter cube. What is the relative molecular mass of the gas, given that the GMV, that's gas molar volume constant, is 22.4 dm cube? So I want to just write the options down. A, 17, B, 32, C, 64, and D, 71. All right. Now I want us to pay attention. So this is it. Let me tell you something very important. This is that regardless if you can solve this question, I want you to just follow me, because there's something I'll be doing in my solution that will help you in your calculation. Because this is a JAMB question. You don't need to waste time to start processing it slowly. Just watch how I'm going to process it. Now, firstly, let's write our parameters down. 0.79 gram. That's a mass. My mass is 0.79 gram. Okay. What else? At STP, occupied a volume of 250. So my volume is 250 centimeter cube. Follow me. Oh. What else? What is the relative molecular mass? RMM is what? Bam. Now, this is what to do. Just follow me. This is what to do. Firstly, there's a formula that you should know as a chemistry student, and the formula is mole is equal to mass over molar mass. All right, hold on, let me change the marker. All right, mole is what? Mass over molar mass. Are we getting me? And this mole is still equal to what? Volume of a substance over volume at STP. Now, I don't want to push further because this is what we know. This is what we need. All right, I can actually write more formulas for you, but that'll be another video. Just check my page. Okay, now mass over molar mass, volume of a substance over what? Volume at STP. Now, what is the mass of this substance? 0.79. Are you getting me? What's the molar mass? Now, the molar mass of the gas, as long as they did not mention the kind of gas, the molar mass will be the same thing as the what? Relative molecular mass. But it's not always the same every time. Are we getting what I'm trying to say? Yes. The relative molecular mass is the okay, no, it's the same thing. This is what we call RAM. RAM are those things that we usually put in brackets. You understand? But yeah, RMM is the same thing. Okay, so now just follow me. Now, what's the mass? 0.79 over what's the molar mass? That's what I'm looking for. Okay, MM. Now, what is my volume? Now, it is going to be very wrong if you are using 250 centimeter cube and the volume at STP that was given. Check the question. The question will appear now. Just check it. You can see that the volume at STP was what? 22.4 dm cube. Dm cube is not the same as cm cube, even if they are cubic measurement. Are we getting me? Now, note this conversion. 1000 cm cube is equivalent to 1 dm cube. Are you following? So if you want to change 250 cm cube in dm cube, what do? Just quickly put 250 here. All right, what do? You put x. Are you following? Cross multiply. X times 1000 times x is what? 1000x equal to 250 times 1, 250. Class, how can you find x? 250 over 1000. Punch your calculator. 250 over 1000. That's going to give you what? 0.25. Follow me. 0.25 is now my volume. And this is what? dm cube. Now you cannot say, okay, 22.4 dm cube. You solve. Cross multiply. 0.79 multiplied by 22.4. Are we getting me? Equal to what? mm times 0.25. What is my what? mm will be equal to what? This whole thing, 22.4 divided by what? 0.25. Now, there's something I want to tell you. This calculation looks very low because I'm teaching. Okay, now if you are giving something like this in your JAMB examination, please don't start trying to use your head to do this thing. You're going to waste your time. There's a calculator there. Even if the calculator is not easy to access, something like this will save time. Are we getting me? So just quickly go there. 0.79 times 22.4. Now calm down. You click your answer. Write it somewhere before you divide by what? 0.25. Now the reason is because most times JAMB calculator might not be following, like the way you press it might not be with board mass. So instead of it to give you a proper answer, it might give you a wrong answer. So when you have gotten this, then before you can divide by 0.25. I hope this is clear. What is the answer on your calculator? 70 point what? My mm is what? 70. All right, 70, approximately 71 gram. What is my answer, class? Option D. So I hope it's clear. It is very, very, very simple. Okay, JAMB chemistry is simple. Just know that, okay, mole is mass over molar mass, volume of a substance over volume at STP, then you solve normally. Question 2. So don't get tired. Now don't pass JAMB 9 the rest. Just pay attention. Question 2. A pressure, you go to this question on your screen now. A pressure exerted by a sample of a gas confined in 5.86 dm cube. So yes, volume is what? 5.86 dm cube. Follow me. Container at 20 degrees Celsius. What's that, class? My temperature. 20 degrees Celsius. Okay, is 4.1 atm. Atm is atmospheric pressure. Are we getting me? Good. So my pressure is what? 4.1 atm. You understand? Now atm is atmosphere, sorry, like it's more like a unit of pressure. Okay, what is the number of moles of the gas in this sample? So what is N? This one should be easy now. It should be easy. Quickly try it, pause it, quickly try it, then continue this video. So option A is 1.0, option B is 2.0, option C is 3.0, and option D is 4.0. Now this is very simple. Class, what are we doing? We are doing what? PV equal nRT. Even if they did not give you R, you should already know the value for R. I've told you before, my R is what? 0.082. Is that clear? Good. What's my pressure? My pressure is what? 4.1. Now class, what's my volume? 5.86. And what's my N? N is my number of moles, and that is what we are looking for, right? Good. My N is N, and my R is 0.082. Now pay attention to this. What will temperature be? If the answer to temperature is 20, then you should go back to this video and rewatch it, because I told you that when you are dealing with ID gas equation, your temperature, in fact, when you are dealing with gas equations generally, Boyle's law, Charles' law, your temperature should be what class? Kelvin. And to convert degrees Celsius to Kelvin, what do? You add 273. So class, this is T equal 20 plus what? 273. That's giving what? 293. Okay, so please let's not forget 293. So let's continue. What's N? N is what? 4.1 times 586 divided by what class? 0.082 times 293. What's my N? All right, quickly punch your calculator. Let's do that quickly. 4.1 times 5.86 divided by 0.082 times 293. So there's something you should know. The answer is 1.00. That's option A. But see, let me tell you something. Pay attention. You know, the reason why most students solve and don't see answer is not because you don't know what you're doing. Actually, to some extent, you don't know what you're doing. Now, this is it. Your calculation might be incorrect. I'm not saying this. I'm saying this. Yes. Most of you can now say 4.1 times 5.86 divided by this. You might get your answer, but please, it is important and is advisable to put this in brackets first. Do this, then divide. Don't mesh together. Mostly for JAMB, there is no time to waste. See, in JAMB is 40 questions. 40 questions for chemistry. In total, 180 questions in 2 hours. If you calculate it, you don't have enough time. So there's really no time to solve and resolve. So from the offset, from beginning, try to be avoiding errors. And one way to avoid error is by doing this, putting in brackets. Are we clear? Let's move to question 3. Question 3. So yes, you're going to see the question on your screen now, right? Just pay attention, don't get tired. A gas occupies a volume of 5 dm cube at 2 atm and 273 degrees Celsius. So yes, if you like, go and use 273 as your temperature. See, let me say something about JAMB. JAMB is very simple, but you have to be very careful. Right? They purposely put this was an intentional value. This was an intentional value. It's not if they just put anyone over. It's an intentional value in the sense that they know that many students will fall victim of using T as 273. Just because maybe you were aware that okay, if your temperature is in degrees Celsius, you have to add 273 to get in Kelvin. Most of them will see this one now and say, oh yes, I don't think I should use 273 again with Kelvin. No. You have to add it, because regardless of this 273 is not changing the rule that when using ID gas equation, your T has to be what class? Kelvin. Good. So 273 plus 273 is what? 546, right? Yes, 546 Kelvin. Now pay attention. Having understood everything, what do? PV equal nRT. Very simple. Let's be fast. What's my P? 2. What's my V? 5. What's my N? We don't know. That's what we're looking for, right? Good. Multiply by what is my R? 0.082. And what is my T, guys? 546. Now let's solve. What is my N? N equals to. So yes, 5 times 2 is what class? 10. Over. Now let's do this. 0.082 times 546. this is going to give me what? 0.22 moles if you press your calculator properly. And from the options in your question on your screen, it is option what, class? Option C. Correct. So I believe this is clear. I hope this is clear. Now, JAMB is not hard. I will repeat, it is not hard. Just make sure that you have an in-depth understanding on the topic. Are you following? Now, let me just give you a summary of everything that I've explained in today's video. So we went through what the meaning of ideal gas, and I said a gas is said to be ideal when it is what? At low pressure and high temperature. A gas deviates from ideality at high pressure and low temperature. Now, what are the factors that are responsible for this deviation? Number one, I made mention of what? High molecular forces. That's when the forces becomes appreciable. Number two, I made mention that when the gas is less energetic, it starts deviating from what? It starts deviating from ideality. Okay. Now, I also made mention of this formula, PV equal nRT. It is used when you want to find PV, nR, and T, and also when you want to find what? Compressibility factor. So please share this video if you like, if you actually enjoyed the video and you learned something. Share the video, subscribe, comment. I'll be in the comment section to answer any questions you have. And yes, if you're a JAMBite, post-UTME student, or any science student at all that wants to know more about other tutorials, check the description below for our website. And yes, feel free to send me hi on WhatsApp. My contact details is on the description below. Thank you very much for watching Ajax Tutorials video. I remain Ajax. See you Ajax Tutorials. Cheers.